A targeted diagnosis and repair plan and maintenance of and for Mini Countryman 1.6 Cooper Chili N16B16A 2014 with error code 3029 sensor neutral position and the message start and stop automatic failure, but usable from a mechanic's perspective. 1. Brief explanation of the problem. Start and stop do not work. Message in display. Error code 3029 neutral position sensor gearbox. Neutral position sensor has already been replaced. Wiring has been measured up to the ECU. Error did not clear and keeps coming back. Reading equipment. Snap-on Hella Gutman Texa. Conclusion. Either the sensor mechanically does not see a real neutral, or the learning procedure does not go well, or there is a problem in the software and ECU and power supplies, or there are conditions that prevent the ECU from accepting the neutral position. 2. Basic checks before in-depth diagnosis. 1. Battery and charging system. Battery voltage at rest, 12.4 V. While walking, 13.814 8 V. Bad battery and charging voltage start-stop is disabled, and sometimes error codes near neutral clutch sensors. 2. Start and stop conditions. Check that all conditions are met. Engine temperature normal, minimum 60-70 degrees C coolant. No active error codes regarding engine, ABS and ESP, clutch, crankshaft sensor, pedal sensors, etc. Air conditioning and climate not at maximum load. When there is a high cooling demand, start and stop are often blocked. Fasten your seat belt, close the door, close the hood, etc. If something is wrong here, solve those faults first. 3. Specific to error code 3029, neutral position sensor. On this Mini manual transmission, there are 3 important inputs for the ECU around start-stop. 1. Gearbox neutral position sensor. 2. Clutch pedal sensor, at least 2 positions. Pressed, released, sometimes intermediate signal. 3. Vehicle speed signal, ABS and DSC. 3. 1. Check live data essential. With Snap-on, Gutman, Texa and live data measurements. Search parameters such as gearbox neutral switch, clutch pedal switch 1-2, start-stop enable, start and stop status, gear engaged, current gear, test, engine idling, car on the bridge or on the floor, gearbox in N and see if neutral switches to ON, active, gearbox in 1, 2, 3 value should be clearly set to off, not neutral. Compare clutch pedal depressed, loose. Check whether the ECU sees this correctly. If live data never shows neutral as neutral, despite new sensor. Focus on sensor installation, mechanical adjustment, or wrong sensor. 4. Check sensor and wiring more in detail. You have measured wiring, but check specifically for 4.1 pin assignment and power supply. Consult diagrams, BMW, Mini WDS or similar for plus 5V or plus 12V reference to sensor. Mass. Signal to ECU. Measuring with contact on. Is reference, voltage on sensor correct? Is ground really ground potential, voltage drop, 0.1 V under load? 4.2, sensor signal shape. Depending on type of sensor. Switch sensor on-off. In N, you should practically see battery voltage or V, depending on design. Outside N opposite value. Hall analog sensor. Voltage changes noticeably when switching N. Acceleration. With multimeter. With connection cable, backprobe to signal wire. In N write down voltage. In gear, note voltage. Difference must be clear, e.g. 0.5 V versus 4.5 V or V versus 12 V. If there is no difference. Sensor defective, new may also be defective. Wrong sensor installed, check number with VIN. Mechanical drive of the sensor is not moved by the switching mechanism. 5. Mechanical control of gearbox and shift mechanism. Check switching mechanism. Does the lever have sufficient free play in neutral? No bent rods, play in coupling piece. Shorter aftermarket lever. Check on the container itself. Is the sensor correctly in its seat, fully screwed in as instructed? No dirt and metal between sensor and associated cam comb. Try to visibly operate the shift rods and top of the gearbox and see if there is a mechanical neutral position that the sensor should see. If everything is correct mechanically, but sensor value does not change back to electrical control or ECU. 6. Learning procedure, learning neutral position sensor. You indicated trying to learn the sensor, but the error code cannot be erased. This is often what goes wrong. 1. Incomplete or incorrect teach-in procedure via universal testers. With BMW and Mini, learning sometimes only works completely with ISDA and D, wrangled. 2. Active error code blocks learning procedure. Plan. 1. Preferably connect the car to BMW and Mini ISDA, dealer or specialist. 2. Job search. Teach-in neutral position sensor, and service functions, drive, DME and DDE adaptations, and clutch or gearbox. 3. Follow the procedure exactly. Ignition on, engine off. Gear lever in N, clutch position often according to instructions, often loose. ISDA indicates step-by-step what to do. If ISDA indicates that the procedure is failing. Often message with reason, e.g. invalid sensor value, not in neutral voltage problem. 7. Check other relevant signals. Because start-stop and neutral position are strongly related to other sensors. 1. Clutch pedal switches. Some Minis have 2 switches. Live data. Is clutch pressed correct, yes or no? Faulty clutch switch can cause the ECU to never see a valid start and stop condition, and sometimes trigger 3029. 2. Brake pedal switch. Wrong brake switch, start and stop disabled. Check live data. 3. DSC and ABS error codes. Driving speed signal required. Faults in ABS and DSC can block start and stop. 8. ECU DME, final step. If sensor new and correct type. Wiring logical and electrically good. Live data shows no change, while you do measure a good signal change on the sensor line at the ECU. Learning does not work, not even with ISDA. Then you can. Defective input in DME, ECU, thinking. Or software problem, DME software update, programming coding. Plan. 1. ISDA and ISDAP or ESIS, dealer. Check for software updates for DME. 2. If no software solution. DME testing at ECU revision specialist. If input is defective, overhaul or replace ECU INCL, coding immobilizer adjustment. 9. Compact repair plan, workshop step-by-step plan. 1. Basic. Test battery and check charging system. Read and resolve other error codes, engine, ABS and DSC, clutch and brake switches. 2. Live data analysis. Check neutral sensor signal at N and gear. Check clutch and brake switches. View start and stop status and blocking reason, often visible as start E-stop not available reason. 3. Sensor and wiring. Check sensor voltage plus 5 and 12V and ground on sensor. Measure signal voltage, multimeter, in N and acceleration. Verify sensor pin assignment and part number, BMW and Mini part number. 4. Mechanical control. Check the switching mechanism and lever for correct operation. Verify sensor installation, depth, mounting. 5. Learning procedure. Use ISDA for neutral sensor adaptation. In case of failure, view error log and conditions. 6. ECU check. With correct signals on ECU pin, but incorrect live data. ECU input suspicious and have it tested, overhauled, and updated. 10. Practical advice for you. Because you have already worked with several universal testers and did not know the error. Next logical step. To a BMW and Mini specialist or dealer with ISDA 2. 1. Live data from Neutral and Link can be viewed exactly. 2. Perform the official learning procedure. 3. Check the software status of the DME. Take with you invoice and details of the new neutral position sensor, part number. Note that wiring has already been measured to ECU. Targeted version of your schedule, specific to Mini car. Mini Countryman 1.6 Cooper Chili N16B16A 2014, petrol. Car information. Make, type, and bodywork. Mini Countryman R60, 5-door crossover SUV. Fuel. Gasoline. Transmission. Usually 6-speed manual or 6-speed automatic. Check for license plate. Drive. Many versions are front-wheel drive, FWD, some all-4 all-wheel drive. Year of construction. Car, first registration 2014, late model R60, after many teething problems. Engine type. N16B16A, 1.6-liter, 4-cylinder petrol, 88 kW and 122 HP, chain motor, direct injection. Known issues, specifically Mini R61.6 N16. Common problems. Timing chain, rack and chain tensioners, less serious than the old N14, but still a point of attention. Oil consumption on some N16 engines. Contamination in the intake tract, direct injection carbon deposits in valves. Sensor problems, including camshaft and crankshaft sensors, lambda sensors. Malfunctions and recalls. Software updates for engine ECU, DME, and sometimes start and stop logic. Check for open promotions via Mini and BMW dealer or RDW. Vulnerable parts. Timing chain set, Vanos adjustment, ignition coils, thermostat and cooling system, start and stop related sensors, clutch, neutral position. Problematic engines. N14, turbo, was more problematic than N16. Your N16 has been improved, but chain and oil use remain a concern. Recommended construction years and versions. R60 after plus or minus 2012 already has many improvements. You are in 2014, so favorable. Well-maintained vehicles with demonstrable oil changes, max 10,000 kilometers, are highly recommended. General diagnosis for your Mini. Diagnostic steps. 1. Describe complaints, such as your start-stop message. 2. Read error codes with suitable equipment, preferably BMW and Mini ISDA. 3. Visual inspection of engine compartment plus underside. 4. Basic check, battery, charging system, fluids. 5. Targeted measurements, sensors, wiring, mechanical checks. Common malfunctions. Start and stop malfunctions, chain noise, irregular running, misfires, error codes of lambda sensors and NOx and exhaust. Diagnostic equipment. Universal, Hella Gutmann, Texa, Snap-on, as you already use. Ideally, BMW and Mini ISD80 for precise functions and learning procedures. Electrical faults. Many issues due to ground problems, bad battery, moisture in plugs. Error codes. In your case, 3029 sensor neutral position, relevant for start and stop. Always note other codes present, ABS, steering angle, airbag, engine. Engine diagnosis, N16B16A. Check mechanical wear. Listening to chain, rattling on cold starts. Oil consumption, check level regularly. Compression. In case of complaints about power misfire, measure cylinder compression. Turbo and injectors. Your N16, Cooper, no S, is naturally aspirated, so no turbo. Injectors. Check for poor starting, irregular running, or abnormal adaptations. Cooling system. Known weak points. Thermostat, plastic connectors, leaks. Incipient engine damage. Long-lasting chain noise, metal in oil, coolant loss, black-blue smoke. Diagnosis, drive and gearbox. Gearbox, manual or automatic. Manual gearbox, control for smooth shifting, no creaks or jumping out of gear. Automatic transmission, if present. Shifting behavior, slippage, jerking may be programming or internal wear. Maintenance. Mini often mentions lifetime oil, but overhaul specialists recommend changing it around 100,000 kilometers, especially with automatic transmissions. Drive shafts and CV joints. Check for knocking, clicking noises when steering and driving away, tears in covers. Chassis and brakes diagnosis. Shock absorbers. R60 is higher, so check for leaks, rust, and play in struts. Brakes. Front and rear discs against rust. Thickness of blocks, handbrake operation, known weaker point if it is rarely used. Steering system. Plays on ball joints, wishbones, rubbers, steering rack, especially at higher mileage. Electronics diagnosis, important for your start and stop problem. Electronic faults mini. Comfort modules, parking sensors, start and stop and clutch and neutral position sensors. Battery and alternator. Crucial for start and stop. Battery condition and correct registration. When replacing the battery sometimes has to be registered in the car. Instrument panel and comfort. Warnings, start and stop notifications, cruise control, air conditioning. Repair and repair plan, tailored to your malfunction. Complaint, start-stop automatic failure, plus error code 3029, neutral position sensor. Replaced neutral position sensor, measured wiring, error probably remains. No valid neutral position information at the ECU. Learning procedure not performed properly or limited by software. Possible ECU, input software problem. Plan specifically. 1 battery and charging system. Test battery, capacity, voltage, and alternator. Start and stop, switches itself off if the battery is weak. 2 live data and ISDA, recommended. Read, neutral position, clutch switches, brake switch, start and stop status plus reason not available. Check whether neutral position actually changes in the live data. 3 sensor check. Check neutral position, sensor part number against VIN. Measure voltage and ground and signal on sensor, and at ECU in N and in gear. 4. Mechanical control. Switch mechanism and sensor installed correctly. No aftermarket short shift mechanism that changes neutral position. 5. Learning procedure for neutral sensor. Preferably with BMW and Mini ISDA. Perform the teach-in neutral position function. If this fails, write down the error message ISDA gives. 6. ECU, DME. If sensor and signals are good, but ECU does not see neutral, have the DME software update performed. In case of persistent error, have the ECU line tested by an overhaul specialist. Parts and labor costs, indicative NL. Neutral position sensor mini, plus or minus 60-150, depending on brand OE. Diagnosis by specialist, plus or minus 1-2 hours, euros 80-150 per hour. ECU software update, plus or minus 100-250, dealer. ECU overhaul, if necessary, roughly 300-800. Maintenance and intervals, specific advice for N16. Oil plus filter, max, every 15,000 kilometers or annually, preferably shorter than long life. Spark plugs, plus or minus 60,000 kilometers, check Mini specification. Air filter, plus or minus 30-40,000 kilometers. Coolant, brake fluid, according to schedule, often 2 years for brake fluid. Annual costs, with normal use plus or minus euros 501,000 years, depending on mileage. Longevity and prevention. N16 chain, with good maintenance often 150,000 kilometers and replace at 100,000 kilometers, but listen for chain noise at cold start. Battery start and stop, plus or minus for 6 years, then risk of start and stop failures. Prevention. Check the oil level regularly. No long oil change intervals. Keep the battery healthy, no structural short trips alone. Purchase and parts and overhaul, short. For your car, 2014. Year of construction is favorable. When purchasing or assessing, focus mainly on chain noise, maintenance history, and electronics. Parts. For sensors, chain, clutch, brakes, preferably OE or A brand. Overhaul. Only in case of real engine damage and malfunctions. N16 is usually easy to overhaul. Maintaining a Mini. A complete diagnosis and repair plan specifically tailored to your Mini Countryman 1.6 Cooper Chili N16B16A petrol, 2014. I keep it practical so you can use it as a mechanic or as an owner. 1. Basic vehicle data. Mini Countryman. Type 1.6 Cooper Chili. Engine code N16B16A, 1598cc, 4-cylinder petrol. Year of construction, first registration July 2014. Transmission in this version is usually manual, but the diagram also applies to automatic transmission, where applicable. Front-wheel drive. 2. Known issues N16B16A and Mini Countryman R60. 2. 1 common problems. Timing chain stretch and wear. Chain tensioners and guides wear out prematurely. Oil consumption by piston rings, valve seals and crankcase ventilation. Contamination of intake and intake valves due to indirect injection and EGR fumes. Ignition coils and spark plugs are sensitive to malfunctions. Thermostat housing cooling leakage. Water pump wear leak. High-pressure fuel pump failures, less than with N14, but still possible. Engine management errors around VANOS and camshaft position sensor. 2.2. Malfunctions and recalls, general internet image. Recalls around cooling fan and wiring harnesses, check and Mini dealer on license plate. Software updates engine ECU, idling problems, emissions. 2. 3 vulnerable parts. Timing chain set. Crankshaft camshaft oil seals. Plastic thermostat housing. Ignition coils and spark plugs. Engine mounts. Crankcase ventilation valve. 2. 4 problematic engines and recommended years of manufacture. N14, older generation, more problematic than N16. N16B16A has been improved, but timing chain and oil consumption remain points of attention. Years of manufacture 2012, 2016 of the Countryman with N16 are acceptable, if properly maintained, oil on time, correct specification. 3. General diagnosis. 3. 1 diagnostic step sequence. 1. Record customer complaint sounds, lights, consumption, power loss. 2. Visual inspection of the engine compartment under the car. 3. Read OBD diagnosis and save freeze frame data. 4. Basic measurements. Oil level quality. Coolant level and leak marks. Battery voltage and charging voltage. 5. Test drive under different loads. 6. Targeted diagnosis based on complaint and error codes. 3. 2 common malfunctions. P0016 and P0017 and P0011 and P0012. Camshaft-crankshaft synchronization. VANOS problems, often due to chain stretch or dirty VANOS valves. Misfire codes, cylinder 1-4 due to ignition coils, spark plugs. Mixture codes, too lean, too rich, due to vacuum leak, air mass meter, fuel pressure problems. Cooling system, error codes, due to thermostat or sensor. 3. Diagnostic equipment. Professional OBD2 scanner with brand support, Mini BMW. Multimeter. Compression tester. Leak test device, cylinder leak down. Smoke machine for vacuum leak test. Fuel pressure gauge. Pressure gauge for cooling system. 3. For electrical faults. Step by step. 1. Test battery under load. Check starting voltage. 2. Measuring charging alternator 13-814, 8V. 3. Check the ground connections of the engine body. 4. Check fuses and relays, interior engine compartment. 5. Signal measurements at sensors, camshaft crankshaft map, MAF lambda, with diagnostic device live data. 3. 5. Read and interpret error codes. Write down codes and view freeze frame. Clear codes and take a test drive. Link recurring codes to mechanical cause, chain stretch, vacuum leak, injector problem. 4. Diagnosis engine N16B16A. 4. 1. Check mechanical wear. Leakage around valve cover crankcase crankshaft seal. Abnormal sounds. Ratchet at cold start chain. Ticking rocker arms valve tappets. Check oil consumption. Customer questions about topping up oil. Exhaust smoke, blue when you release the gas and then accelerate. 4. 2. Measuring compression. 1. Engine at operating temperature. 2. Switch off fuel injection and ignition, fuses or plugs. 3. Remove spark plugs and install compression tester. 4. Fully depress the accelerator pedal and start until the meter is stable. 5. Measure and compare all cylinders. Deviation between cylinders maximum, approximately 10-15%. Low compression plus oil in cylinder may indicate piston rings or valves. 4.3. Turbo and injectors. This engine is naturally aspirated in the Cooper, no turbo. Check injectors. Leak test, pressure drop after shutdown. Balance via OBD, correction values. Spark plug image per cylinder, wet black and white. 4.4. Cooling system. Visually check thermostat housing and hoses for leaks. Pressure test on cooling system. Check cooling fan operation, switch on points. Temperature live data. Thermostat that remains open too early and too late gives too low an operating temperature. 4.5. Recognizing early engine damage. Metal shavings in oil or sump plug. Strongly rattling chain during cold starts or speed changes. Knock noise under load, bearing damage. Higher oil consumption, combined with blue smoke. 5. Diagnosis of drive and gearbox. 5. 1. Gearbox problems. Manual transmission. Difficult shifting or grinding clutch pressure group synchronizations. Vibration when accelerating clutch disc, flywheel engine mounts. Automatic if present. Jerky shifting, contaminated oil, defective valve block software. 5. 2. Check for wear and oil. Check the dipstick filler plug for metal particles of discolored oil. For automatic, assess oil quality and change interval, preferably preventively around 120,000 kilometers. 5. 3. Maintenance. Change manual transmission, oil around 150,000 kilometers, even though the manufacturer often says lifetime. Check the clutch for slippage during a test drive. 5. 4. Drive shafts and CV joints. Check play by moving shafts by hand. Clicking noises when turning in completely while accelerating the outer CV joints. 6. Chassis and brakes diagnosis. 6.1. Shock absorbers. Visually check for oil leakage. Push test and test drive. Nave jumps on thresholds, bounce. Unrounded tire wear. 6. 2. Brake components. Measure the thickness of brake pads and discs. Rust on disc edges. Check the handbrake function. 6. 3. Problems with braking. Vibration when braking, warped discs. Pulling away when braking, uneven braking power, stuck brake caliper. 6. 4. Steering gear. Clearance between ball joints, tie rod ends and control arms. Slight knocking at irregularities in the control arm rubbers and stabilizer bars. 7. Electronics diagnosis. 7.1. Electronic malfunctions. windshield wiper motors, central electronics unit, window adjustment errors, central locking. Moisture in engine compartment plug connections. 7. 2 battery and alternator check. Battery age often 5-7 years. Starting voltage, not below approximately 9.6 V. Charging voltage 13, 814, 8 V stationary. 7. 3 instrument panel comfort electronics. Check for error messages in the central display. Seat heating, air conditioning radio, often fuse or ground fault. 8. Repair and repair plan. 8. 1. Drawing up a plan. 1. Safety critical matters first, brakes, tires, suspension. 2. Then engine technically crucial points, timing chain cooling system, oil leaks. 3. Then comfort and electronics. 8. 2. Prioritize inspection and replacement. Order for your Mini. 1. Timing chain and related parts. Necklace. Tensioners. Conductors. Check camshaft adjusters. 2. Cooling system. Thermostat housing. Water pump. Hoses and clamps. 3. Inflammation. Spark plugs replace in time. Ignition coils in case of misfire or old age. 4. Oil and filters. Engine oil with correct specification. Oil filter. Air filter, fuel filter, cabin filter. 5. Suspension and brakes. Worn brake discs, shock absorbers and suspension arms. 8. 3 urgent replacements. Address rattling chain immediately. Immediately detect and repair coolant loss. Do not continue driving the misfire under load due to the risk of catalytic converter damage. 8. 4 original and imitation parts. Cooling system distribution, kit preferably OEM or A brand. INA SKF Gates Mall. Brakes also A brands, 8 Bosch TRW. Ignition coils spark plugs, preferably OEM specification. 9. Costs of parts and labor global estimate in the Netherlands. Front brake pads, about 80–150 euros. Front brake discs and pads, approximately 200–350 euros. Shock absorbers per axle, approximately 250–450 euros. Battery, about 120–200 euros. Timing chain set complete. Parts approximately 300–600 euros, labor 6–9 hours. Hourly wage universal garage, approximately 70–110 euros. Small turn. Oil filter, air filter, cabin filter checkpoints. Costs about 200–400 euros. Major service. Extra, spark plugs, brake fluid, air filter, cabin filter, more inspection. Costs approximately 400–800 euros, depending on work. 10. Maintenance and intervals. 10.1. Maintenance intervals. Oil and filter ideally every 15,000 kilometers or 1 year, no longer waiting. Spark plugs usually around 60,000 kilometers. Cabin air filter 30,000 kilometers, 40,000 kilometers. Brake fluid every 2 years. Coolant 5 years, or according to factory specification. 10. 2 annual maintenance costs. Average 400–800 euros per year, depending on mileage and condition of the car. 11. Part lifespan. Battery 5–7 years. Starter motor alternator, often above 150,000 kilometers when used properly. Shock absorbers around 120,000 kilometers, 160,000 kilometers. Clutch depending on driving style, 100,000 kilometers, 200,000 kilometers. 12. Prevention of future problems. 12. 1 maintenance measures. Short oil change intervals. Only oil, according to manufacturer's specifications. Always fill and bleed the cooling system in time when carrying out work. 12. 2 driving style. Do not load the engine at high speed when it is cold. Regular longer journeys to limit condensation and pollution. 12. 3 liquids and oils. Engine oil, correct viscosity according to Mini specification, For example, 5W30 long life fully synthetic, depending on prescription. Only high-quality coolant suitable for BMW Mini. 13. Purchase used Mini Countryman N16B16A. Important when purchasing. Maintenance booklets and invoices available. Evidence of regular oil changes. Ask specifically about timing chain complaints or replacement. Check oil level and possible smoke. Have a test drive, an OBD scan performed. 14. New or used parts. Motor and safety-critical parts, preferably new or overhauled with warranty. Used parts acceptable for interior body parts and sometimes electronics, if tested. 15. Engine overhaul or replacement. Overhaul in case of structural oil consumption, compression loss. Bearing damage. Costs for overhaul N16, generally €250–450, depending on size and workshop. Replacement motor, reconditioned used, often comparable or slightly more expensive but quicker to install. 16. Gearbox repair or replacement. Manual gearbox, overhaul in case of noise or slipping out of gear. Overhaul costs €100–200, depending on damage. Replacement box often costs €800–150 plus installation. 17. Choice of petrol or diesel. For this model and year in the Netherlands, petrol is usually more sensible because fewer problems with particulate filter EGR high-pressure injection on short journeys. Lower risks of expensive diesel repairs, EGR DPF turbo. 18. Summary advice for your Mini Countryman N16B16A. 1. First, perform diagnosis according to steps: OBD compression smoke test, chain noise cooling system. 2. Assess the timing chain status, and if in doubt, replace it preventively. 3. Check the cooling system and replace weak points, water pump thermostat housing, preventively in case of age or leakage. 4. Perform complete maintenance with correct oil and filters. 5. Completely check the chassis brakes and replace wearing parts. 6. Maintain an annual maintenance plan with short oil intervals and regular checks of coolant and oil level. Schedule still to be maintained. Extra. Mini maintenance. Inbox. Diagnosis and repair plan for your Mini Countryman 1.6 Cooper Chili N16B16A from July 2014 on petrol. 1 Vehicle and engine details. Mini Countryman. Type 1.6 Cooper Chili. Engine N16B 16A 1598cc 4-cylinder petrol. Year of construction, first registration 2014. Drive 2 wheels, front-wheel drive. Transmission manual or automatic depending on version. 2 known issues. 2. 1 common problems according to technicians and owners. Timing chain that stretches and rattles, especially during cold starts. Worn chain tensioner and plastic guides. Oil consumption due to piston rings, valve seals and crankcase ventilation. Ignition coils and spark plugs that regularly fail and cause misfires. Coolant leakage at the plastic thermostat housing. Water pump that may leak or make noise. Contamination in the intake and on valves can cause rough idling and loss of power. Camshaft adjuster problems and error codes on VANOS. Sensor problems such as camshaft and crankshaft sensor. 2.2 faults and recalls can be found on the internet. Software updates for engine ECU. Possible recalls for cooling fans and wiring harnesses. Always check recalls on license plate at RDW and Mini dealer. 2.3 Vulnerable parts. Timing chain set including tensioner and guides. Thermostat housing and cooling water hoses. Water pump. Ignition coils and spark plugs. Engine mounts. Crankcase ventilation parts and valve cover. 2.4 Problematic engines and recommended years of manufacture. Older N14 engines are more problematic than the N16. The N16B16A in your Mini has been improved, but remains sensitive to chain stretch and oil consumption. Years of construction, 2012 to 2015, are usable provided that maintenance has been demonstrably done on time. 3. Diagnosis general. 3. 1 diagnostic steps. Record customer complaint. Visual inspection of engine compartment and underside of vehicle. Read OBD error codes and store freeze frame data. Perform basic checks. Oil level and oil quality. Coolant level and leaks. Battery voltage and charging voltage. Carry out a test drive with a cold and warm engine. Then targeted diagnosis per system based on complaints and error codes. 3.2 Common malfunctions. Engine rattling during cold start due to timing chain. Error codes on camshaft positions and crankshaft positions. Misfires due to ignition coils and spark plugs. Mixture codes too lean or too rich due to vacuum leaks or mass airflow meter problems. Cooling system error messages due to defective thermostat or sensor. 3. Diagnostic equipment. Professional OBD diagnostic tester with Mini and BMW support. Multimeter. Compression tester and leak test equipment. Vacuum leak smoke machine. Fuel pressure gauge. Cooling system pressure tester. 3.4 Electrical fault checking. Test battery for voltage and capacity. Test the alternator for charging voltage. Check ground connections of engine and body. Check fuses and relays. View live data from important sensors such as crankshaft sensor, camshaft sensor MAF lambda, and coolant temperature. 3.5 Read and interpret error codes. Register all error codes. View freeze frame info to see conditions. Clear error codes. Take a test drive and read it again. Link recurring codes to mechanical or electrical causes. 4 Engine diagnosis N16B16A. 4. 1 Check mechanical wear. Check oil leakage around valve cover, crankshaft seals, and oil pan. Listen to the chain rattling, especially when starting from a cold start and when you release the gas and accelerate again. Listening for ticking valve tappets or rocker arms. Check oil consumption and check level. 4. 2 Measuring compression. Bring the engine up to operating temperature. Switch off fuel injection and ignition. Remove spark plugs. Install compression gauge per cylinder. Start at full throttle until the value is stable. Measure and compare all cylinders. Large deviations indicate valve or piston ring problems. 4.3 Check injectors. Measure fuel pressure and check pressure drop after shutdown. Assess spark plugs per cylinder for color and combustion. If in doubt, have the injectors tested and cleaned or replaced. 4.4 Cooling system inspection. Check the coolant fill level and color. Check thermostat housing and hoses for signs of leakage. Perform a pressure test on the cooling system. Check the operation of the cooling fan. Monitor engine temperature with diagnostic device. 4. 5 Recognizing early engine damage. Metal particles in oil or on sump plug. Strong rattling from the bottom of the block, indicating bearing damage. Blue smoke from the exhaust when you let off the gas and then accelerate. Persistent low compression on 1 or more cylinders. 5 Drive and gearbox diagnosis. 5. 1 Gearbox problems. Difficult to put into gear or creak with manual gearbox. When the clutch slips, the speed increases without a corresponding acceleration. With automatic transmission, jerky or delayed shifting and slipping when accelerating. 5. 2 Checking wear and oil. Check oil leakage at the gearbox and drive shafts. For manual transmission, check oil level and quality and replace if necessary. For automatic transmission, oil quality and possibly change according to manufacturer or specialist. 5. 3 Maintenance frequency. Change manual transmission, oil preventively around 100,000 kilometers. Depending on the type and advice, automatic transmission oil is usually between 80,000 kilometers and 120,000 kilometers. 5. 4 drive shafts and CV joints. When turning in and accelerating fully, listen to clicking noises. Check axles for play and torn covers. Greasy deposits around CV joints indicate cracks in the cover. 6. Chassis and brakes diagnosis. 6. 1 shock absorbers. Visually check for oil leakage. Check for uneven compression and approach after a threshold. Assess tire wear for cupping and irregular wear. 6. 2 brake components. Measure the thickness of brake pads and brake discs. Assess rust and gouges on discs. Check brake lines and hoses for rust and cracks. 6. 3 problems with braking. Vibration in the steering wheel or pedal during braking due to warped discs. Pulling to one side due to uneven braking power or stuck caliper. Soft pedal due to air in system or internal leak in master brake cylinder. 6. 4 steering gear. Check play on tie rod ends, ball joints and control arm rubbers. When driving over speed bumps, listen for knocking or banging around the front axle. Check the steering rack for leaks and play. 7. Electronics diagnosis. 7.1. Electronic malfunctions. Malfunctions in central comfort module. Problems with windows, central locking and lighting. Radio and air conditioning malfunctions due to power supply or ground problems. 7.2. Battery and alternator check. Test battery for starting power and internal resistance. Measure charging voltage at idle and at loads such as lighting and air conditioning. Check battery, drain for parasitic current. 7. 3 instrument panel and comfort electronics. Check for error messages in the display. Check lighting meters and warning lights. Test the seat heating and air conditioning function. 8. Repair and repair plan. 8. 1. Drawing up a repair plan. First, assess all safety-critical points, brakes, tires, steering, and suspension. Then there are engine technical risks, such as timing chain oil leakage and cooling system. Then comfort and electronics. 8. 2. Prioritize inspection and replacement. Priority 1. Check the timing chain set, and, if in doubt, replace it completely, including tensioner guides, and if necessary. Camshaft adjusters. Check cooling system, and replace leaking thermostat housing and water pump. Repair major oil leaks. Priority 2. Replace spark plugs and ignition coils if faults or age are present. Perform maintenance with engine oil, air filter and cabin filter. Check brakes and brake fluid, and replace if necessary. Priority 3. Shock absorbers, suspension arms, engine mounts and other chassis wear parts. Comfort electronics and disturbing, but not critical errors. 8. 3 urgent replacements. Rattling timing chain. Strong coolant leakage. Misfires under load. Braking problems such as vibration or significantly reduced braking power. 8. 4 original and imitation parts. For engine and safety parts, preference is given to original or equality brands. Brakes, shock absorbers, distribution kit and water pump preferably from well-known brands. For the interior and bodywork, imitation or used parts are often sufficient. 9. Cost of parts and labor indication. Average prices in Europe, including VAT, but excluding exact workshop rates. Timing chain set parts about 300 to 600 euros, and labor about 6 to 9 hours. Water pump and thermostat housing parts about 200 to 400 euros, and labor about 2 to 4 hours. Brake discs and pads for the front axle approximately 200 to 350 euros. Shock absorbers per axle approximately 250 to 450 euros, depending on brand. Battery about 120 to 200 euros. Hourly wages at Universal Garage, usually between 70 and 110 euros. Small turn. Oil and filter and basic check, average 200 to 400 euros. Big turn. Extra filters, spark plugs and brake fluid average 400 to 800 euros, depending on what is included. 10 maintenance and intervals. Oil and filter, every year or every 10,000 kilometers. Spark plugs approximately every 60,000 kilometers. Air filter and cabin filter every 30,000 kilometers to 40,000 kilometers. Brake fluid every 2 years. Coolant around 5 years, or according to factory. Average annual maintenance costs between 400 and 800 euros, depending on mileage and condition. 11-part lifespan and replacement needs. Battery approximately 5 to 7 years recognizable by difficult starting and voltage drop. Starter motor and alternator often above 150,000 kilometers, but depending on use. Shock absorbers usually 120,000 kilometers to 160,000 kilometers, recognizable by rough handling and uneven rebound. Clutch strongly depends on driving style, usually between 100,000 kilometers and 200,000 kilometers. 12. Prevention of future problems. Change oil regularly and on time with the correct specification. Check the oil level often, especially if oil consumption is known. Drive the engine slowly when warm and avoid high revs when the engine is cold. Never allow the cooling system to continue running with a leak. At the first signs of chain rattle, diagnose immediately and do not delay. Use suitable engine oil according to Mini specification. For example, a fully synthetic 5W30 or 5W40, suitable for BMW long life, depending on regulations. 13. Purchase used Mini Countryman N16B16A. When purchasing, pay attention to maintenance history with invoices. Ask specifically whether the timing chain has ever been replaced. Check oil consumption and exhaust smoke. Take a test drive and listen carefully to the engine. Always have OBD diagnosed for hidden error codes. 14. New or used parts. Use new parts for engine internal parts, brakes, and suspension. Parts used, possibly for bodywork, interior, and some electronic components. Price difference between new and used is often 30 to 60%, but warranty and reliability are more important for critical parts. 15. Engine overhaul or replacement. Consider overhaul if there is high oil consumption, low compression, or bearing damage. The costs of a complete overhaul of this engine are roughly between 250 and 450 euros, depending on damage and parts. Replacement engine, used or overhauled, comparable or slightly higher, but often quicker to install. 16. Gearbox repair or replacement. If there are heavy noises or gears jump out, an overhaul may be necessary. Manual transmission overhauls often cost between 100 and 200 euros, depending on damage. Used bucket can be cheaper, but with less security. 17. Choice of petrol or diesel. For this Mini, gasoline is usually the sensible choice. Fewer problems on short journeys. No particulate filter, and less risk of expensive EGR and high-pressure diesel problems. 18. Summary advice and concrete plan for your car. First, perform a complete diagnosis with OBD reading, visual inspection, and test drive. In case of a rattling chain or matching error codes, have the timing chain completely replaced. Check the cooling system thoroughly and have the thermostat housing and water pump replaced if necessary. Carry out a complete service with the correct oil and all filters and spark plugs. Inspect the brakes and chassis and replace wearing parts immediately. Then follow annual maintenance with short oil intervals and regular oil and coolant checks. Convert it into a short workshop form with point-by-point steps for diagnosis and repair, especially for this Mini, without additional explanation. Workshop form diagnosis and repair. Mini Countryman 1.6 Cooper Chili N16B16A 2014 petrol. 1. Basic information. License plate. Type Countryman 1.6 Cooper Chili. Engine code N16B16A petrol. Mileage. Transmission manual or automatic. 2. Diagnosis general. 1. Record customer complaint. 2. Visual inspection of engine compartment and underside. 3. Check oil level and oil quality. 4. Check coolant level and leakage. 5. Measure battery voltage and charging voltage. 6. Read OBD error codes and save report. 7. Perform a test, drive cold and warm. 8. Plan targeted diagnosis based on complaint and codes. 3. Engine diagnosis. 1. Listening for timing chain, rattling on cold starts. 2. Check oil leakage around the oil pan valve cover and oil seals. 3. Compression test all cylinders. 4. Remove and assess spark plugs. 5. Visually check the ignition coils and replace them if necessary in case of misfire. 6. Check vacuum leakage with smoke test. 7. Cooling system pressure test. 8. Check injectors via OBD correction values and spark plug image. 4. Diagnosis of drive and gearbox. 1. Test drive on shifting and noise. 2. Check clutch for slip. 3. Check gearbox for leaks. 4. Check oil level and gearbox quality. 5. Check drive shafts and CV joints for play and boots. 5. Chassis and brakes diagnosis. 1. Measure brake pads and brake discs thickness. 2. Check brake lines and brake hoses. 3. Check shock absorbers for leaks and function. 4. Check tire tread and irregular wear. 5. Check ball joints and tie rod ends for control arms. 6. Test drive for vibration and pulling when braking. 6. Electronics diagnosis. 1. Start battery test and load. 2. Measure alternator charging voltage. 3. Check fuses and relays. 4. Full OBD, scan engine and ABS and airbag and comfort. 5. Instrument panel and lighting control. 6. Control comfort functions, windows, central locking, air conditioning. 7. Repair plan priority. Priority 1. Safety and preventing engine damage. 1. Assess timing chain status. 2. In case of ratcheting or error codes, replace chain set, chain and tensioner. Guides and necessary bolts and gaskets. 3. Remove cooling leakage from thermostat housing and water pump if necessary. 4. Repair serious oil leaks. 5. Replace brake pads and brake discs if below minimum or warped. Priority 2. Reliability and driving comfort. 1. Replace spark plugs if term has expired or wear. 2. Replace ignition coils in case of misfire or old age in consultation. 3. Complete maintenance. Engine oil and oil filter. Air filter. Cabin filter. Fuel filter if applicable. 4. Change brake fluid if older than 2 years. 5. Change gearbox, oil is recommended. Priority 3 remaining points. 1. Replace shock absorbers and wishbones if they are worn. 2. Replace engine mounts if excessive vibrations occur. 3. Troubleshooting comfort electronics. 8. Parts indication for main repairs. Timing chain set complete. Valve cover gasket and any seals. Thermostat housing. Water pump. Spark plugs complete set. Ignition coils if necessary. Oil and filters. Brake discs and brake pads if necessary. 9. Work sequence for major engine repairs. 1. Disconnect battery. 2. Remove engine covers and necessary parts. 3. Drain the cooling system when working on the water pump and thermostat housing. 4. Remove the timing cover and accessories. 5. Replace timing, chain kit, according to factory procedure. 6. Change engine oil and install new filter. 7. Fill and bleed the cooling system. 8. Start the engine and check for leaks and noise. 9. Test drive, and then final inspection reading and visual inspection. 10. Final inspection and reporting. 1. OBD check error codes after repair. 2. Check the test drive for noise and power. 3. Leakage check engine and cooling system and braking system. 4. Maintenance advice and any future expected repairs should be stated on the work order.